Find the rational zeros of p of x equals x to the fourth minus 5x cubed minus 5x squared plus 23x plus 10. Write p of x in completely factored form. To factor a polynomial like this would just be crazy, just trying to look at it and figure out how to factor it. We've got a degree 4 polynomial here, there's really no way to make sense of how we would factor this. So we need to find the zeros first, and we will begin by using the Rational Zeros Theorem, because that tells us what the possibilities are for our rational zeros. So our Rational Zeros Theorem says we're going to take the integer factors of our constant term and divide by the integer factors of our leading coefficient, which in this case is just 1. So the factors of 10, integer factors, are 1, 2, 5, and 10. And it's plus or minus, of course, all of those, plus or minus. And we divide by the integer factors of 1. And the integer factors of 1 are just 1 and plus or minus, okay? So we get our plus or minus, and then each of these numbers divided by 1, and that just gives us the list plus or minus 1, 2, 5, and 10. And these are the numbers that we're now going to try and see if they work as in our polynomial to factor out. So we do synthetic division. We list the coefficients of our polynomial. So 1, -5, -5, 23, and 10. And out here, we'll just start with our small numbers. So we'll start with 1 here. We pull down the 1. 1 times 1 is 1. -5 plus 1 is -4. 1 times -4 is -4. -5 plus -4 is -9. 1 times -9 is -9. 23 plus -9 is 14. 1 times 14 is 14, and 10 plus 14 is 24. We didn't get 0 here, which means that x minus 1 is not a factor, or in other words, 1 is not a 0. And so now we just get rid of this work because it didn't work out for us, and we move on to our next number in our list to try out. So I'm going to go ahead and try -1. We bring the 1 down. 1 times -1 is -1. -5 plus -1 is -6. -6 times -1 is 6. -5 plus 6 is 1. 1 times -1 is -1. 23 plus -1 is 22, and -1 times 22 is -22. Add those together and we get -12. Again, we did not get 0 here, so -1 doesn't work either. So we get rid of our work and move on to the next number in our list, which will be 2. And you don't have to go in a specific order. You can go in any order you want. I just like working with the smaller numbers because the work is, arithmetic is a little bit easier. So if I do 2 here, bring the 1 down. 1 times 2 is 2. -5 plus 2 is -3. -3 times 2 is -6. -5 plus -6 is -11. 2 times -11 is -22. 23 plus -22 is 1. 1 times 2 is 2. 12 plus 2, or 10 plus 2 is 12. And this is not 0 either. So 2 doesn't work. So we move on, and we'll try -2 next. So we bring the 1 down. 1 times -2 is -2. -5 plus -2 is -7. -2 plus times -7 is 14. -5 plus 14 is 9. -2 times 9 is -18. 23 plus -18 is 5. And 5 times -2 is -10. And we add those, we get 0. So -2 worked for us, and that's nice. So now we check another number, okay? And when something works, you should try it again, because that's a 0, but it may be a 0 of multiplicity 2 or 3, who knows? And so let's go ahead and try that. We bring the 1 down. 1 times negative 2 is negative 2. Add those, we get negative 9. Negative 9 times negative 2 is 18. Add those, you get 27 times negative 2 is negative 54. Obviously, we are not getting 0 here. So negative 2 doesn't work again. All right, so now we can move on to 5. And by the way, okay, one little trick you can do is at this stage, the rational zeros theorem still applies. So the zeros of this actually still have to be in the form of a factor of 5 divided by a factor of 1. Okay, so factors of 5 now are only 1 or 5, and we don't, 1 didn't work, and negative 1 didn't work. So now we know that our answer has to be 5 or negative 5 for our remaining zeros. Let's go ahead and try 5. Bring the 1 down. 1 times 5 is 5. Negative 7 plus 5 is negative 2. Negative 2 times 5 is negative 10. 9 plus negative 10 is negative 1. And negative 1 times 5 is negative 5. Add those and we get 0. All right. Now we got 0 here. So 5 worked. And notice, if we think about that same trick that I mentioned, the remaining zeros would have to be of the form, rational zeros would have to be of the form a factor of negative 1 divided by a factor of 1. And 5 does not match that, nor does negative 5, nor does 10 or negative 10. So, since we've already tried 1 and negative 1, we know that negative 2 and 5 are our only rational zeros. So, that means x plus 2 is a factor, x minus 5 is a factor, and what's left is here x squared minus 2x minus 1. Okay. Now we want this in completely factored form, but this doesn't have any rational zeros. That means we need to go on and find irrational zeros. But because this is a quadratic, we can find those zeros by using the quadratic formula. So the quadratic formula, x equals negative b, 2, plus or minus the square root of b squared, negative 2 squared, minus 4 times a times c, all over 2a. Well, we've got 2 plus or minus, this is the square root of 4, minus a negative, so plus another 4, and divided by 2. Well, that's the square root of 8, and the square root of 8 simplifies to 2 root 2, because 8 is 4 times 2, and the square root of 4 is 2. And we divide that by 2, and that cancels these 2's here. We get 1 plus or minus root 2. That tells us that 1 plus root 2 is a 0, and 1 minus root 2 is a 0. Those are not rational because we've got that square root of 2 in there. So to write it in completely factored form, we've got these rational 0 factors, and then for each of these we have a factor. So we have x minus 1 plus root 2 and x minus 1 minus root 2. And there's our completely factored form of our polynomial.